करता हूं मैं प्यारे बच्चों, dear students, I welcome all of you to the chemistry class of class grade 10 on the date 13/11/2020. Today we will study mostly about the various homologous series that we have started studying. Now you can see on your screen something. So my dear students, in the previous class, dear students, in the previous class, we have studied about the alkanes. We have seen that the general formula for alkane was CnH2n plus 2. Now, in this class, we are going to study about the general formula for the alkenes, alkynes, and some other groups. So, let's start our study, my dear students. Let us first study about the general formula for alkene. The general formula for alkene is CnH2n. Ethene is the first member of alkene homologous series. Now, when we study about the alkanes, my dear students, the first member, what we have studied was methane. And methane has got only one carbon. But we know that alkenes have at least one C double bond C. And to have at least one C double bond C, we need two carbon. And that is why the first member of alkene is ethene, where we have two carbon. That means when we have the word eth, it represents the two carbon. So ethene means the alkene having the two carbon. So we can say N is equal to 2. As we have N is equal to 2, my dear students, instead of N we can write 2. So we will have C2H2 into 2, and finally we get C2H4. And this is how, my dear students, we get the molecular formula for ethene as C2H4. Now, if we go to the next member of the homologous series, we should take N is equal to 3. When N is equal to 3, we have the word prop. So prop represents N is equal to 3, or prop represents 3 carbon. So we will have the alkene, that is ENE. We just add ENE to the propane. So we will add PROPENE. So we will have propene. The propene will have the general formula C3, because N is equal to 3, C3 into H, 3 into 2. When we have C3 and even we will have H3 into 2, we get C3H6. This is what it is, the second member of the alkene homologous series. And we have the formula of propene as C3H6, my dear students. Now, if we take N is equal to 4, that means we will have 4 carbon. So we will have but. See, if we take N is equal to 4, for CnH2n, we will write C4H2 into 4, that is your C4H8. So for butene, we can write, or we can have the molecular formula C4H8. Same way, my dear students, for pentene, we can write C5H10. So now, my dear students, you must have understood that some particular word represents the number of carbon. Let us look at these particular numbers that represents the various numbers of carbon, my dear students. Let's have a look to them. So first, if we look at the word which is known as the eth, then this eth represents 2 carbon. Prop, that represents 3 carbon. But, that represents 4 carbon. Pent, that represents 5 carbon. Hex, that represents 6 carbon. Hept, that represents 7 carbon. Oct, that represents 8 carbon. Non, that represents 9 carbon. And dec, that represents 10 carbon. Please remember, my dear students, that these are the word that represents the number of carbon. And once again, eth 2 carbon, prop 3 carbon, but 4 carbon, pent 5 carbon, hex 6 carbon, hept 7 carbon, oct 8 carbon, non 9 carbon, and dec 10 carbon. Now, according to the general formula, CnH2n, we can write for ethene it is C2H4. For propene, we can have C3H6. For butene, we have C4H8. For pentene, we have C5H10. For hexene, we have C6H12. For heptane, we have C7H14. For octene, we have C8H16. For nonene, we have C9H18. And for decene, we have C10H22. So this is how, my dear students, we can easily understand about the various alkenes, and these are known as homologous series. Please remember, my dear students, that these homologous series, each member differs with the preceding and succeeding member. Each member differs with the preceding and succeeding member by CH2 or by 14 U mass. Remember, in the homologous series, each member differs with the preceding and succeeding member with CH2 or by 14 U mass. So now, my dear students, we want to study about the alkynes. These alkynes have at least one C triple bond C. So this is how we study about the alkynes. They are having the at least one C triple bond C. So general formula for alkyne is CnH2n minus 2. Now, as it requires at least one triple bond between the carbons, and that is why, my dear students, we can easily say that the first member of the alkyne homologous series must have two carbons. And two carbons, that is eth. So the first member of the alkyne homologous series will be ethyne. So this is how, my dear students, we can easily understand that ethyne is the first member of the homologous series of our alkynes. So the first member of the homologous series of alkyne is your ethyne. Ethyne has two carbon, but the general formula is CnH2n minus 2. So we can write C2H2 into 2 minus 2. That means C2H4 minus 2, and that is C2H2. So for ethyne, my dear students, we can easily write C2H2 as the molecular formula. Same way, my dear students, for propyne, we can take 3 carbon. So for propyne, we can write C3H3 into 2 minus 2. That is C3H6 minus 2. That is C3H4. So for propyne, my dear students, we can write C3H4. For butane, you know but means 4 carbon. So we can write C4H4 into 2 minus 2. That is C4H8 minus 2. That is C4H6. Same way, my dear students, we can write for all alkynes. The general formula for alkyne is CnH2n minus 2. So we can write ethyne, propyne, butane, pentyne, hexyne, heptyne, octyne, nonine, and decyne. Same way, eth means 2 carbon, prop means 3 carbon, but means 4 carbon, pent means 5 carbon, hex means 6 carbon, hept means 7 carbon, oct means 8 carbon, non means 9 carbon, dec means 10 carbon. And that is why we can write the general formula C2H2, ethyne C2H2, propyne C3H4, butane C4H6, pentyne C6, propyne C6. Just hold on, my dear students. I have got a call. I'll just. Yes, dear students. So this is how we can write the various formulas for the homologous series of the alkynes. So it is easy for us to study about the various alkynes and their homologous series. Now we can move to the next part, my dear students. So when it comes to the next part, we can move forward and study. Let's have a look to this. After alkynes, my dear students, we want to study something else. Let us go behind and look forward for the hydrocarbon compounds. In the hydrocarbon compounds, we have open chain hydrocarbon and cyclic hydrocarbons. In the open chain hydrocarbons, my dear students, we have acyclic hydrocarbons which do not have cycles. So the another name for open chain hydrocarbon is acyclic hydrocarbon. But we may also have cyclic hydrocarbons or ring hydrocarbons or closed chain hydrocarbons. So we can have various types of hydrocarbons. We can have the cyclic hydrocarbons, we can have the ring hydrocarbons, we can have the closed chain hydrocarbons. These closed chain hydrocarbons or ring hydrocarbons maybe are of various type, but we have seen that we have got the various open chain hydrocarbons like alkanes, alkenes and alkynes, and the general formula for alkane is CnH2n plus 2, general formula for alkene is CnH2n, and general formula for alkyne is CnH2n minus 2. Now, my dear students, we are going to study about the cyclic hydrocarbon or ring hydrocarbon or closed chain hydrocarbon. So here we can write some of the examples of these cyclic hydrocarbons like cyclobutane, cyclopentane, cyclohexane. And the general formula for the cyclic compounds is going to be CnH2n. So let us study about the various cyclic compounds, my dear students. So now, my dear students, we are going to study about the closed chain or the closed chain compounds or the ring cyclic compounds or ring compounds or the cyclic hydrocarbon. So here we are going to study about the closed chain hydrocarbon, ring hydrocarbon or cyclic hydrocarbon. The closed chain ring or cyclic hydrocarbon have the general formula CnH2n. So the first member of the homologous series must have at least 3 carbon, because only with the 3 carbon we can produce ring. So only 2 carbon cannot produce ring, and that is why for the homologous series of the cyclic closed chain or ring hydrocarbon, we must have the first hydrocarbon that must have the 3 carbons. So here we have N is equal to 3, and that is why we will have C3H6 as the product. So my dear students, we can easily understand that we have C3H6, which is the first member of the closed chain or ring or cyclic hydrocarbon. You can see here that we have cyclopropane that has C3H6. You can see that we have 3 carbons bonded in the cyclic manner. So we will have CH2 bond CH2 bond CH2. Same way, my dear students, we have cyclobutane. So this cyclobutane has N is equal to 4. So we will have the general formula CnH2n. As we have the general formula CnH2n, we may have C4H2 into 4. And this is why, or this is how we get C4H8. You can see that these 4 carbons are bonded into the this way. You can see this is carbon 1, 2, 3 and 4, and this is how, my dear students, we get cyclobutane, which we have CH2 bond CH2 bond CH2 bond CH2. So next, my dear students, we can move to the another homologous compounds. We can move to N is equal to 5. So my dear students, when we have N is equal to 5, we call the compound as cyclopentane. As the general formula is CnH2n, we can easily write C5H2 into 5, and that is what it gives us, the C5H10. You can see this is the formula for cyclopentane here. So this cyclopentane shows us this way we can get the cyclopentane. Same way, my dear students, we can go for the cyclohexane. So in cyclohexane we have N is equal to 6. Again the general formula is CnH2n. So we will write C6H12. You can see in the cyclic ring, my dear students, we can have this cyclohexane. Now there is one more compound which is known as benzene. This is a special compound that we study in 10th standard. Benzene has got the formula C6H6. Same like cyclohexane, benzene has also got 6 carbon bonded with each other in the hexagon, but there will be alternate double bond. You can see this is first bond, this is second bond, this is third bond. So we get 3 alternate double bond, and that is why the number of hydrogen is decreased by 6. And this is how this alternate double bond system, this is alternate double bond cyclic system is known as the that we can see here, and this particular system is known as the benzene. So we even study the structure of benzene where we have the alternate double bond. This is also a cyclic compound, but as it has got some special characteristics, and that is why this particular compound is known as the aromatic compound. So benzene is an aromatic compound. These are not aromatic compound, but both benzene and cyclobutane, cyclopentane, propane and cyclohexane, they are all cyclic compounds, and they are hydrocarbon because they are made up of only hydrogen and carbon. Now, my dear students, we have studied about the hydrocarbons. These hydrocarbons have only 2 elements. They are the hydrogen and then we have carbon. So we have hydrogen and carbon. These 2 elements are present at a time. That is how they are known as the hydrocarbons. But apart from the hydrogen and carbon, my dear students, apart from this hydrogen and carbon, carbon can form compounds. Those have atoms like chlorine, fluorine, bromine, iodine, oxygen, nitrogen, sulfur, phosphorus, etc. Please remember that carbon can make compounds with this chlorine, fluorine, bromine, iodine. They are known as halogens. Then oxygen, nitrogen, sulfur, phosphorus, and some other elements too. So this is how, my dear students, we can have the various compounds formed by carbon by combining carbon with these elements. These atoms are found as a functional group. Please remember that in the compounds of carbon, these atoms are found as a functional group. So we call them as a functional group. Now let us write the definition of the functional group. Please learn this definition because you may be asked this definition in your exams. So I would recommend you to learn this definition of the functional group. So please learn the definition of the functional group. What is the definition of the functional group? Let's have a look. An atom or a group of atoms structured in unique fashion, reactive side of the compound, and responsible for all chemical properties or all chemical characteristics of the compound is known as the functional group. I am going to repeat it for you once again. An atom or a group of atoms structured in unique fashion, reactive side of the compound, and responsible for all chemical properties or all chemical characteristics of the compound is known as functional group. Now I'm going to explain you each and every step or each and every line one by one. Let's have a look to the each points, my dear students, that we have seen into this. So what are the various points that falls into the category or that falls into the definition of the functional group? You can see here the first point for the definition of the functional group is an atom or a group of atoms. What does it mean? It simply means that the functional group can be a single atom. The functional group can be a single atom or it can be more than one atom. That is why we call it group of atoms. So functional group can be single atom or a group of atom. Second, structured in unique fashion. Please understand this word unique. What is the meaning of the word unique? Unique means special. It means that the structure of this functional group is unique, it's special and not similar to anyone else. The another meaning of unique is not similar to anyone else. The meaning of unique is not similar to others. Not similar to anything. So please learn or please understand that the structure of the functional group is unique, it's special, and it is not similar to the another functional group. And that is why we write structured in unique fashion. Reactive site of the compound. Site means area. Site means area. So what does this statement means? That whenever there is a reaction takes place on the compound, this reaction first takes place on the functional group. So whenever there is a reaction that takes place into the carbon compound, that reaction is going to be taken place on the functional group itself. So please remember, my dear students, that functional group is the reactive side of the compound. Whatever the chemical reaction takes place, this chemical reaction takes place on the functional group itself, and that is why functional group is the reactive side of the compound and responsible for all chemical characteristics or responsible for all chemical properties of the compound. So whatever the chemical reaction takes place, that chemical reaction takes place on the functional group. Functional group is same in every compound of the homologous series. So all the compounds having same functional group in a particular homologous series will have same chemical properties. And that is why, what are the chemical properties of any compound? These chemical properties of any compound depends upon the functional group of the compound. So this represent or the functional group is responsible for every chemical property of the compound. Now, my dear students, we are going to study something else. We have already seen about the functional group of the compound. Now let us study something else. Let us have a look at this. So we have studied about the functional group. Now we want to study something else. Compound of carbon having functional group. Let us look at their structure. So here, if we have the compound of carbon, which is another than the hydrocarbon. So now, if we have the another compound of carbon, which is not a hydrocarbon, then the compound of carbon, which it must have a functional group, because these elements are found as a functional group into the carbon compound. So if the compound of carbon contain the elements like fluorine, chlorine, bromine, iodine, oxygen, nitrogen, sulfur and phosphorus, they must be as a functional group. So compound of carbon having functional group has two parts. The first part of that carbon compound is known as the functional group. The another part of the carbon compound is known as the skeleton. So you can see here that I have shown you the carbon compound. This carbon compound has a two part. One part is known as the skeleton, and skeleton is made up of the carbon and hydrogen only. But the another part is known as the functional group, and this functional group contain the element other than carbon and hydrogen. So this functional group, you can see we have oxygen and hydrogen. So element other than uh, carbon and hydrogen must be seen into the functional group part. You can see that we have oxygen seen into this part. Remember that hydrogen can be or carbon even can be into the functional group. Carbon and hydrogen can be in the functional group. Please remember that carbon and hydrogen can be in the functional group. But we must have at least one element other than carbon and hydrogen. So you can see here, we have oxygen present here as an element other than carbon. So this is how, my dear students, for the carbon compound, we have two parts. One part is known as the skeleton, another part is known as the functional group, my dear students. So this is how we study about the various parts in detail. Now, my dear students, we are going to study in detail about the next part. Let us have a look to this. Instead of, see, in standard 10, my dear students, we need to study following functional groups. So we will study the functional group like chloro functional group, we will study bromo functional group, we will study iodo functional group, we will study fluoro functional group. These functional groups are made up of single atom. Please remember that these functional groups are made up of single atom. We have already seen that functional group can be an atom or a group of atoms. Now, my dear students, we will study about the functional group that contain oxygen. So we will study the functional group that contains oxygen, oxygen as a functional group, or functional group that contain oxygen. So you can see here that when we have a functional group containing oxygen, my dear students, we have first functional group which is known as alcohol, which is represented by OH. We have the another functional group which is known as aldehyde, which is represented by CHO. We have the third functional group which is represented, which is known as ketone, which is C double bond O, or then we have the fourth functional group which is known as the carboxylic acid that has a specific structure of C double bond O and O and H. And then we have the fifth functional group which is known as the ester, which is having the functional group C double bond O bond R. This R is known as the alkyl group. Which may be methyl, that is CH3, it may be ethyl, that is C2H5, or maybe something else. So this is how, my dear students, these are the various uh, functional group that we are going to study into these particular standards. Now let's move to the next part and understand it. Let us have a look to the various homologous series of these compounds. So there are homologous series made by the compounds containing functional group. Compounds containing functional group may also have the homologous series. So let us have a look to the various homologous series that are found into this particular compound. Let's have a look to this. First, we should study about the homologous series of alcohols. So the homologous series of alcohol, we have methane. This methane, you can see in methane we have METHANE. We replace this E. We replace this E and we replace one of the hydrogen. So one hydrogen is replaced by OH. One hydrogen is replaced by OH. So you can see instead of H we have written OH. So finally we get methanol. This methanol has got a CH3OH. So while giving name, the E from methane is removed and OL is added, and that is why we get methanol. The same we can do for all the other compounds in the homologous series of alcohol. So same way, my dear students, you can see we have written for one carbon we have written methanol, for two carbon we have written ethanol, for three carbon we have written propanol, for four carbon we have written butanol. For 5 carbon we have written pentanol, and for 6 carbon we have written hexanol. Now you can see that this CH3 and OH is already there, but there